So welcome to this evening. It has been a while before we ran such a session because of the field work that has been made. But we'd like to take you through this session on the process of analyzing your data. Your data is currently the engine by which almost all organizations are using to make what we call decisions concerning way forward, the best alternative course of action that they need to take so that at least they can push in some of the key variables that may be affecting their performance or may be affecting the changes in the livelihood of people and etc. Just based on the environment upon which the data is being analyzed. That these are general cause. But then we have specific data analysis for monitoring and evaluation. We also have data analysis for what we call health care clinics, health care, the so-called biostatistics. So each and every data analysis now can be taken to the area where it deserves. But then this is for researchers, those who are aspiring perhaps to be researchers in future. Perhaps you want to use it as one of the avenues of earning income. Actually, this is one of the areas that is paying a lot, especially when your jobs fails. This one will not fail you. So it's one of the skills that is very critical if at all you have it, especially in our current society where you are not sure whether you will work for the next 2 or 3 years. But this one will not, because even when you look at the institutions, several institutions are not offering this particular training. They expect the students doing their postgraduates to go outside there and analyze their data, but then they don't give them perhaps the basic knowledge that they require so that they can be able to analyze data themselves. So they just resort to looking for people who can be able to analyze for them the data they have, and they pay hence some good amount of money. So instead of such a skills, instead of paying others, especially for the postgraduates students, it's better you have all about you learn it. So I just want to take you through briefly on this concept, how to analyze your data. Now, this perhaps I organize it for those who are in monitoring, evaluation, accountability, and learning, but it also cut across even for the researchers in other fields, because this process remains the same, regardless of the kind of profession that it's supposed to be used for. But then when now it comes to specifically the analysis itself, now the data, we shall take live data for specific scenarios. Like if it is monitoring evaluation, then it will be specifically for the monitoring evaluation department data set that will be used for conducting what we call analysis. If it is for a student, then we take a topic and perhaps now we take the key variables and then we continue with doing such kind of analysis. So we often gather information to learn new things. We solve problems in our day-to-day life. And this brings us the main reason why we analyze data. This gathering information require the process we are calling as data collection. And we have various ways by which you can be able to collect this data. Sometimes we can just use what we call a documentary analysis, and we can also have what we call the questionnaires we give to the respondents, and we collect the information. And currently, we normally use a lot of what we call the programs, system technology way of collecting data. Then it becomes in a certain interface called the CSV file. Then after that, we can be able to transfer it to various softwares that we are using for what we call data analysis. Now, the quantitative data analysis that we are going to talk about, we have softwares that supports quantitative analysis. One of it is the use of Microsoft Excel. We configure Excel, and when we configure Excel, we can use that Excel now to analyze our data. However, Excel may have some limitations, especially when it comes to now doing advanced analysis. But Excel is one of the most powerful tools that is used for what we call data analysis, and we simply do program it so that it can fit the analysis. But mainly, the basic analysis like descriptive statistics, all of them Excel can analyze so well. And also just few inferential statistics where we are trying to compare the relationship between variables. Excel can analyze to some extent. Excel is also a very powerful tool that we use for what we call data visualization, presenting very beautiful graphs. You can use that Excel. Okay, but it is at the lowest level of data analysis in the quantitative format. However much in NGO field, Excel is enough for you to work comfortably well in your data. Yeah, most of these reports that you read outside there, they are either using the lower level tools to analyze them. You may find the kind of analysis there is very simple and very straightforward. So learning Microsoft Excel, especially with the specific mind of using it for analysis, is very, very important. And we also have SPSS, which is a statistical package software we are using for what we call conductive analysis. This our training. We are going to use two softwares, Excel and also the SPSS. We also have Stata, which is both used manually and also used as a program. And then we have R, which is sometimes called the regression. It is a very powerful tool that is used for supporting the data science. And also it can be used to analyze very complex data. And then we also have what we call the Python, is also another one that can be used. Yeah, we have different kind of software that we can be able to support our analysis. But just knowing 2 or 3 of them is very important, especially when you want to venture into the world of research. And then even if you're a student, having known a few software will give you a plus, especially when you go to the interview. When they take you to the practicals, you'll be able to indicate that perhaps you went to school really. Rather than someone analyzing for you data, you only go and do the presentation, and then you cannot be able to know the complexities involved in analyzing those data. It's not very good. At this place, we train. These data analysis softwares programs are a little bit expensive, especially when you go through what you call the consultancy. You will find that you hardly pay less than 100,000 Kenya shillings or $1,000 in order for you to learn the package software for only 5 days, full board. But we decided to make it a little bit more cheaper, that we only charge around 5,500 for our online training program. Yeah, it's not very expensive, and we have trained so many people who currently are analyzing. Others are in the research field, and they are just using the knowledge that they acquired from us to analyze their data. So data only becomes useful when you give the meaning to it. Often data comes in raw form, and there is nothing you can learn from a raw data. And that's why we take you through this process of getting the meaning out from the raw data that you collect from the field. And in that, you learn various ways of presenting it. And the most important thing that I normally take my participant through is the concept of doing what you call data interpretation. Being able to actually use the figures and give figures proper meaning aligned with the context of what you are trying to investigate or what you are trying to find out. So that's what we are normally call as interpreting the data. Remember, before we begin any research, we are normally guided by what we call the problem statement. So when I come to analysis, I will be so much particular trying to dig in to what these figures vis-a-vis the problem that we are trying to investigate. This is a very important process, and it's one of the processes that people do not know. So even to those who tend to analyze data, they don't properly map the data with the main thing that we wanted to find out. So when I will now go and take you through how every problem, looking at the causes of that particular problem, and if we do nothing on that problem, what likely going to happen to that target population? Those are the areas that our figures will be able to relate to. So we shall be mapping. Each and every question becomes a variable in our questionnaire, and each question must be properly be mapped with our key objectives that we wanted to find out, or our key problem that we wanted to solve. So that is the process that we're calling as data interpretation. And once we have done it, we do presentation and then we interpret those particular results. Yeah. And in the field of NGOs, we normally use the graphs, the pictorial approaches in presenting the results. Why do you use that? This is being supported by the concept of the data science. Visual display provide a level playing ground for even non-statisticians to be able to understand our findings. And they try also to relate to it because human beings are more visual as opposed to words. So we like pictures. We try to associate more with pictures. And that is why advertisers take advantage of that to put billboards just using what we call beautiful pictures. It draws attention. It captivates. And that's all what you require with the current human beings. They are very poor in reading, but they will be able to listen. They are so much in social media. They are also able to see. So we use their visual to bring their attention to the result that we are trying to present to them. And in that case, we are going to increase the level of people participating in reading what we wrote. That's the essence why we are going to use more visual. But when it comes to academic work, the presentations will be based on each and every university's requirement. So some universities may require a combination. Some will only specifically tell you about, can you use tables? And if it is like that, then specifically go to the APA tables that they require, or any other format of table system which is specified according to the style of writing in your university. So each and based on the area, the analysis and presentation approaches will change. Yeah. Even when I'm doing what you call now the research for my PhD, then I will be expected now to even go to the extent of doing what you call discussing the key findings. That is not done perhaps when I'm doing some other surveys with the intent of an organization or something like that. It may not be. We only reach perhaps the interpretation, and the interpretation must be very thorough. But in academics environment, things now change based on perhaps the format that the university provide. Okay, so I'm giving you here now an example of a raw data form. You can see the way, at least when we put data in Excel, how it looks like. Remember, Excel is box kind of like this. So we may decide to say respondent questionnaire identifier. This is like the ID, identification of each and every respondent. Now, Excel has what you call the columns, and then there is also what you call the rows. So the rows actually in Excel are numbered, 1 up to very many numbers down there. But then when you come to up here, it's also numbered, like the C1 or C1, etc. But here we have simply indicated our first variable under the vertical column. But this variable is called age, which means we are trying to investigate those people who participate in filling for us this questionnaire. What is their age? What are their various ages? So like, for instance, VIR1 is an identification for the first respondent. It may be Otieno, it may be Opio, or it may be Kamau. But this individual is aged 27 years. Okay, when I come to the second individual, is aged 53 years. Then the third one is aged 19 years. The fourth one is aged 21 years. In that order, until all the people who participated in this particular survey has responded to the question number 1, age. But when I put age like this, sometimes it has a challenge. The challenge is age as a numeric variable sometimes elicit few responses. And that's something that you must take note when you are going now to comprehensively be a researcher. The reason why this may elicit some few responses, you may find one particular gender that does not want to disclose their age. And they will leave this question. They will not write their age in numeric form. So we as the researcher will often try to group this age into categories. But then when I go ahead to put age into a category, then I definitely increase my response rate because like women, mostly they don't like the issue of trying to give them a questionnaire where you ask them to indicate their age. No. So in order for you not to leave a lot of blank spaces in between this particular variable, then you put this age in what you call a category. So when you put in the category, we may say something like 25 to 30. That is an age range of around 5 years. So it's a little bit accommodative for them. And they can be able to take it very well because definitely it means it only falls within that particular age bracket and not mentioning a number. But men do not care much with the concept of releasing their age. Actually, they even might prefer the more age they are, the better they feel like. But remember, the other gender, they don't like. So if that is the case, then, and you're dealing with more of your respondents are women, or they're a balanced kind of the respondents, then it is better you put that age in the bracket. Number of households. Yeah, we go to one particular household and we want to know how many people are living there. So one person, 2 people, or 4 people. Now, when we talk about number of households, especially in monitoring and evaluation, we are so much interested in either some element of consumption. And we want to look at to what extent does household this consume this particular utility that we are providing as the NGO. So in this particular case, it was an issue related with water. So they are trying to understand what exactly is affecting what we call the usage per liter in each and every household. So an household with this particular number of people, how many times can they even walk to go and fetch water in a particular one day? So those are some of the issues that we are trying to investigate. So number in the household, so listed all around. Now, when it is listed like this, like 1, 2, 3, 4, 5, what can we be able to, when we are going to analyze, what are some of the information we can drive here? One information is that we can be able to understand the range of households from the highest to the lowest. One household can accommodate up to how many people? So we can find 10 based on the where you're investigating. There are some communities in our country which even one house, there are 10 people staying there. They like that environment of many people. Others, they just like being in the nuclear ones only. So this age, as presented in terms of age and also number of household in number, we can get the average. So we talk about the average household in this particular community. Then I can budget consumption based on the average. When I want now, like I'm a government official, I want to supply some of the foodstuffs. Then I use the average now, at least to multiply times the number of households that we already have in that particular community, and the budget and the number of sacks that I need to distribute to them so that they can be fed perhaps in 1 month. Especially when I'm doing what you call food program. Okay, so our age-wise is very important also because remember, age is a reflector of productivity. Now, the specific age where we expect people to be more productive. Yes, and then there's a specific age where people are tending to retirement. So they are taking a leave from what you call productive activities. Now, in that particular manner, I need to budget in terms of health based on age, average age. When the community is tending towards too old, many people being old, then it simply means taking care of the old require some behavior change in terms of the supplies of various commodities that the age require at that particular time. So we shall talk about their things like social welfare needs to be improved, intensified in that particular community, as opposed to when we are dealing with the young people. Even the disease burden actually increases by what we call age. So that's why, as I will be talking about the average age, I know if the average age is of this productive level, then how can I have harvest? How can I have maximize their effort in turning them to a developed community? Yeah, so I'm looking at it in that particular perspective. Those are some of the things that I've been looking at. Yeah, then I come to perhaps use of water points. So they are even accepting that they use water points. That is question number 3. Then one only said no. So others accepted yes. When a data set is configured in terms of yes, no, first of all, we consider these particular variables that are going to not in numbers as they're coming under what you call category. Yeah, specific individuals will either fall in one category or 2 category or 3 category. So, but there's no, it is not an issue of a number now, which means this particular kind of variables are called categorical variables. Category. But these ones that are coming in numbers are called numeric. Numeric. Yes, they are numerical variables. Understanding variables is very critical when you are going to do analysis. Actually, there's no one who can do that analysis without understanding variables very well and their classification, because the basis of analysis is to choose a particular statistical tool based on the variable type, which simply means when somebody now asks you, what are the critical factors that influences how that analysis is done? One of it is the nature of the variable. And the variable can be either in numbers, responses that come in numbers. Like for instance, you go to an household, you ask them, how many children do you have? Now, the response you expect from each and every household will be, I have 2 children. I have none. I have 4. I have 5. So all the responses will be a number, and this number are whole number. Will be no household that will tell you that, do you know what? Here I have around 3.5 children. Yeah. There will be none telling you. They all will be whole numbers. Animals you keep whole numbers. So, as we shall be going deeper to understand these variables, we shall know that all the variables that come in whole number are actually called discrete. They are discrete. So, for a variable to be discrete, it means the response I expect from the respondent will be whole number. There will be nothing of decimal associated with that particular response. And then some of the other, and this whole number, I normally call them countables, which means I get the result after head count. 1, 1, 1, 3. I do head count to get my discrete variables. For those who are doing their postgraduate studies, these are most of the questions that they test you in that paper called Statistics Theory paper. So they normally leave those elements of trying to make you understand the nature of the variable, because this is a basis for our data analysis. We can never analyze any data without understanding the variables very clearly so that you can know, treat each and every variable where it belongs to. Another set of variables that we normally have is an instance or a case whereby I've taken an instrument. The instrument may be a ruler, the instrument will be a tape measure, the instrument will be maybe a thermometer, that is an instrument, and it may be a weighing balance, that is an instrument. And then I get the result as a result of the instruments. So it may be height, my height of Peter Nyachome. Height of Peter Nyachome cannot, mostly may not be a whole number because it is not counted. You cannot get my height by counting, but you can get my height by measuring. So any variable on this Earth planet where you measure to get the result are normally classified as continuous variables. They often comes with what you call decimals. So one of the classical example of a variable that comes with the decimal is age of the respondent. The age you are seeing here is not age. This is an approximation. The exact age must have decimals because by the time I'm saying I'm 45 years or I'm 43 years, I've left the number of months associated with, I've left months, I've left some weeks, I've left some seconds, some days. And age is interesting because even by the time we started this particular training, our age has increased. It is a quantity that continues to increase at every second passing by. And that's how it is very important that this particular age is a measurable quantity. It's a measurable, often age should be decimal. It will be 27 point something. So when you're counting them in terms of months, it must be like that. Others is like my weight. My weight, I cannot just go and count. No, you don't count. You don't count. And it's not a discrete variable. I take an instrument, I measure my weight, and when I measure my weight, like right now, I just measured some few hours ago, I found myself to be around 71.2. So now look at that. 71.2, that's my weight. Yeah. So it is not a null number. It's as a result of an instrument that was used. So it is called continuous variable. Yeah, those two are all numbers. All the variables that comes in numbers can be categorized into those categories. When I come to analysis, there will be statistical tool that I will be so much interested to pick when the data set is coming in continuous or discrete. Then I come to this category, yes, no. This is a category of yes, no. Yes, no is very common, especially when we go to what we call biostatistics. Yes, no responses. You are trying to attest a disease. There is a test that we are conducting on a disease. The result for the test of patient number 1 can only be in positive or negative. There is no middle ground. Yes, no. That is a response that only comes in 2 categories. When a response comes in 2 categories, we call them binary. Binary. A response that only comes in 2 categories. It's called binary. And I say it's very common, especially when we are dealing with health statistics. Statistics are associated with health. There is so much responses that come in binary. Responses that comes in binary. So a response that comes in binary, we shall be expected to code it because there is a part that we will talk about coding. We code it in terms of dummy. Yeah?
Yeah. Yeah. Limited time.
Yes. Someone is actually very happy. And let's try to mute the level of happiness. Good, good, good. So a response that come in binary, we often code it in what you call using dummy variable. Now, there's another big term that I'm using here. It simply means when I go to the field trying to investigate what is it that is making women to join entrepreneurship in our country, Kenya, then I will go to respondent number 1, and I will find that this woman is in business. So when I find you in business, I will take yes. If I find you are not in business, you are in employment, I will take no. The subject of the study was about women in entrepreneurship. So a woman being in entrepreneurship, I will code 1 because that is the variable of interest. We call it variable of interest. I code 1. But when I find otherwise, I code 0. So the coding of 0 is a reference. It is for me to talk about the prevalence. Like when it's a disease, I'm looking for the prevalent rate of HIV/AIDS in a particular area. Then I take blood test of sample number of patient 1. I find the person is positive. I code 1. Number 2, I find negative. I code 0. So I will look at from 0 to 1 of a sample of 10, how many are positive? Because remember, the concept of positive is my research investigation. So I will say that out of the 10 I've sampled, I've found 6 positive. Then I come up with some statistical data that 60% are positive in this particular locality, just to heighten the intensity of you getting infection is somehow higher. Because if you can spend with different two people in that particular community without protection, definitely you have it. Because of that 60%. You only have one chance that one person maybe, you may go away with it. But if you repeat the same action in the second party in that community, there's very high chances that you already have it. But if you repeat it 3 times, then there's chance is that you can never escape without having it. The probability of getting it now increases significantly because of that particular prevalent rate, which we got as a result of the coded 1 positivity. So we look at it scientifically in that particular perspective. Then I come to frequency of water point usage. This is another discrete variable. Distance is an ordinal measurement. It's not an ordinal measurement, but it is a measurement that we call from 0 to 1. Is a ratio, kind of. And then we have diarrhea incidences. No, yes. No, yes. This is another category, which is classified into 2 categories only. Now, I have my data. I've got my raw data. But immediately I see my data, I start looking at my data, going over my data, and trying to look at, is the data going to make sense when I go to the analysis component? I scan through my data. So this is what we are calling as raw data. And often when we are going to do our quantitative analysis, we shall transform this particular raw data to our software. And immediately we go there to the software, we shall begin now the process. So let's proceed. So now, the terms here, So I'm introducing you now to various terms that we are associating with the process of data analysis. So data analysis is a process of bringing order and structure to the collected data. The raw data, we need to bring order to it. We need to bring some element of structure to it. And we shall go deep into understanding our data through the process of analysis. And even before we begin analysis, we shall take that data through what we call screening. Screening is like now trying to ensure that our data is of less error as much as possible, because data from the field may be associated with several errors that we shall be able to look at later. But then I will also try to look at, I will also run that data against some statistical investigation. And this statistical investigation will be able to reveal for me the pattern structure of the kind of respondents that I was dealing with. Then I will also try to look at the variability from one particular person to the other. How do they respond? Because if these people were subject to the same environment, they need to have a response which almost similar. But when I find there a very big variability, I need now to investigate, because some element of variability will be as a result of people who are not supposed to fill that questionnaire filled it. They don't have any knowledge concerning whatever we are investigating. So that are some of the things that we are going to go deeper to understand. And it will be very, very important that I go deep to investigate my data structure. I need to run my data against some of the preliminary statistical statistical measurement, so that I can be able to understand that data before I can begin the analysis process itself. Outliers will be investigated. Those are like extreme values. Like for instance, you're investigating some responses in schools, and then you go to a particular grade and you find somebody aged 20, an age like a grade 5, and you find somebody aged 27 years. You cannot now add that 25 years with the average age of 9 or 8 or 10 years of majority of the class members, so that you talk about the average age in that particular class. So this extreme, this value, which is 27, is far much away from others. And therefore, I will ignore it. I will not include it. Or the best way to do is to get the average age and then give it an average age if I don't want to delete, because perhaps there are other responses that he contributed to. So I don't want to delete that particular response completely. So what I do is I provide an average age for it, so that it does not affect the final response on terms of the average age. Because remember, a statistical tool like mean is very sensitive to those extreme values. And in case I include that particular extreme value, what will happen is that the average that I will provide is misleading. And that's what I don't want. I want the information I'm passing to the field outside there is more real as much as possible, with just very few insignificant variation that cannot alter the final result. We are building like even accountant. Accountant uses some terms like they can only accept a value which looks like insignificant, immaterial, is insignificant values. So when we are going to do our analysis, the cleaning process will make us have a result that you can rely on, a result that will remain consistent regardless of the person who is doing the investigation. The result will still be the same. And it meets the standards of a research. Then the concept of data visualization is the process of putting data into a chart, into a graph, or into other visual format that help the analysis to be more easy, help inform the analysis, and provide a communication tool for majority of us who never stepped in a statistical class. When we are trying to communicate something that is going to affect the majority, look at the field of monitoring evaluation. Majority of the data that's being collected are collected among the poor households. It's collected among the vulnerable. It's connected among the disadvantaged members of our community. These people, by and large, may not have that higher level understanding that associated with education. They may have not undergone a lot of education levels we have undergone. So, but the information we shall provide must be useful to them. So, how can we make our report be more friendly to support even their level of curiosity so that they can understand our report well? It's only through using those beautiful pictures. And here we have one of the softwares we normally train here. Power BI is a very powerful tool that provides very good displays in terms of the graphs. So data visualization also help you interpret and communicate your result to everyone that needs to see this result. Result is not only meant for the office, no. Results, especially for data, is meant so much to the users. The beneficiaries must be able to be given this particular report, and the beneficiaries are supposed to be guided so that they understand the report. It helps people see, it helps people interact, and better understand the data. And in that position is where, if it was the issue of a disease, people get alert, they get aware, and they adopt what you call better practices. And that is what we wanted as the people who are doing the research. We wanted people to change their behavior. There was a behavior change program that we are running. So unless we create that platform where the communication tool is accommodative, the communication tool is friendly to the users, then we have not yet reached there. So we can only reach when we provide a very friendly platform of presenting our report. That brings the reports team is very critical if we want to achieve something from the data that you are analyzing. Then we also have another term here called data cleaning. We shall come for this now in the practical when you go to the software component. The data cleaning is crucial step in the data analysis, and you can never ignore it. But this is the step that is being ignored by everyone. I've interacted with data from different places, especially since I started going online in the YouTube with the presentation in data analysis. I've got students from different universities, even in the US. And then, surprisingly, majority of them are doing postgraduates. So, when they give me their data, because the system in the US is that you provide the raw data, you analyze your data, complete everything, but then that particular raw data, you must be able to provide it to, you send it to your supervisor. So that the supervisor will be analyzing as he checks your report and your finding to confirm whether you are cooking the result that you have written there. Okay. So one thing that I may be able to tell you is that majority of them, they take the data, key everything in the software, and begin analysis, bypassing the data cleaning process. And when they send the result to their supervisor, surprisingly, the supervisor presumed the data had been cleaned already. So he also just analyzed it, and the data was not clean. So when these particulars, some of them get to me, I take the data through the cleaning process. You see there's a big variation between the result I'm producing and the result that they were producing the other side. I'm telling that this of mine is correct because this your data, you never subjected it to several tests. One of it is some of the missing values were not replaced. They are still there, the missing values, and the data was run with some of the respondents not filling some questions like the case that I'm talking about, age. Another instance is outliers were not detected and perhaps rectified in the data set. The data set is being run with several outliers, strange, extreme values inside it. And as a result of that, they are providing for us the mean. And the mean definitely is not, cannot be relied on because it is affected by the outlier. So if you know your data was not cleaned and you want to run statistic of calling the mean, no, bypass the mean, go to the median. You can report median or report mode, which are less insensitive to outliers, and still the result is going to be correct. Yeah. So I eliminate a lot of errors. I eliminate typo errors that were associated with the traditional data clerks. Currently, we don't have that particular role because there's a lot of changes in our research, and one of it is that the keying in of entries one by one is no longer there because we use technology to collect data and then we just import. And after importing, begin cleaning. That's some of the process that now we shall be able to take you one by one. But we must also take you to the traditional approaches, how it was being done before, where the data clerks were having a lot of roles to do. It was very tedious work. Currently, the work is more friendly. You only need to get the knowledge and tips of doing it right. So, cleaning process, just like you are cleaning your house, you're making your house organized, you're making your house neat. So, so do we do to the data. So we clean our data, remove extreme values, inconsistencies in result, we try to eliminate. We also try to fix in the missing values, responses that were not attended to, we try to fix them in, okay? And then we also try to detect whether we have duplicate entries. And in case they are duplicate, we try to test the genuineness of the duplicate. Are they duplicate as a result of, in reality, that I'm aged 44 and another person presenting the age 44, and it is reality that all of us are 44 years age, or it was an error. So when we have duplicates, we need to investigate whether it's an authentic case so that we uphold to it, or it is a duplicate as a result of an error. So for the ones for errors, we try to rectify. Yeah. And our software is very powerful, is able to detect all the duplicates aside. Then you go to now investigating one by one. Then we also have what you call data interpretation. This is what I told you is hardly being done properly by several people. People go for training, but then the training is like a half-baked. They don't go deep into this concept of data interpretation. It is the process of attaching meaning to data. Every figure, 40%, must have a meaning which is attached to the subject of our investigation. This is problem statement. So we are going to interpret our result, and our source document of interpretation is what made us to set out to do this investigation. If it is business case-wise, you are trying to look at the productivity, those figures must be mapped with the productive index which we wanted. Okay? And this is a very, actually, when you do this one properly, if you do this one properly, where even age must be interpreted, even we are marital status must be interpreted. Any question that was in the questionnaire must be interpreted. There's no question that you go and write, you tell us 40% were male, 60% were female, and then you run to the next question. At least now you have done your analysis. Those are rubbish. Don't do it like that. When it comes to analysis, you interpret the meaning of that 40%. What is the significance of that with regard to what you are investigating, the 40% and the 60%? What about that variation of 20? What does it reflect? What is the meaning for that? We want to get meaning for those figures. And every figure, we are so much interested in what we can learn from it. What is it telling us? Yeah? To an extent that if you behave like that throughout all your documents, the document is going to be very comprehensive and is okay. Now, if you are doing your PhD result, and then it comes to that, you're doing also the discussion of the findings, then you will find that you will have there's going to be a lot of meat in what you are presenting there. And I normally advise people that don't think that you must write your report. You must do those higher level statistics is when you are communicating, you're doing your data analysis. No. If you sample a lot of reports presented online where data was analyzed, you will find out of 10 reports you will copy online, which were done by those even international organizations, you'll find the main basis of analysis is descriptive statistics. Now, what does that tell you? You can do a descriptive statistic without going to running those relationship tests, and you write your report and you go and get your money. But before you do that, you must interpret the result very comprehensively within what you're trying. And that's why we normally, at that higher level of doing what you call consultancy work of data analysis, we normally recommend you provide questionnaires, analyze all the content of questionnaires. You can go to the detail of doing interpretation, but it is better after you have analyzed and understood the key questions and their findings well, then go now to conduct your interviews. You are going to do interview just trying to investigate some of the things that are not very clear in the questionnaires that you analyzed. You're already going there with some knowledge. So when you go there with some knowledge, you are now going to do what you call thorough, detailed, in-depth analysis concerning what you are seeing here in the quantitative result. Then after that, you come and beef up these qualitative aspects. We beef them up with the quantitative component of the result. And that particular document is going to be very comprehensive. Anyone reading it will require to go. You will require more of it at every moment of sentences that you are writing there, because it's quite detailed. And those are some of the reports that we use for what we call decision making, because it is thoroughly done. You are not going to sketch, do things as somebody who has not gone through what we call proper training on the data analysis. This is the engine of the organization. And since the current engine and every work that involves research, this is one of the most important areas least understood. People take it also for granted. Others even rely on subletting their work to other people. Even if it is consultancy work, you give it to other people, but you want to wait to see how the interpretation is done. Surprisingly, even this in our country, when you go to our libraries in our country, and you go to library and you go to the place called where the PhD reports are, and you check the quality of the work there, of majority of students who graduated right now, they're doctors. One thing that you're going to realize is that there is some gaps in the analysis. And what is bringing the gaps in the analysis is who is these people who are analyzing these reports. These mainly are guys. I even did a quick survey on the people analyzing PhD results in our country. I found that these guys do a certain course in the university called Applied Statistics. But then these guys majority of them are undergraduates. So they cannot go to that in-depth level of bringing a lot of meat to those figures the way it is expected, what I'm trying to explain here. So as a result of that, you find that if you, the person they were trying to analyze for you the result, if you cannot add, if you cannot do the interpretation yourself, they will give you the figures, but they will not be able to bring in what is actually required when it comes to data interpretation. So that is what is spilling over to a lot of gaps in the dissertations that are there in the selves. The interpretations are not properly done because of who is doing it. But if you get somebody who is the level of education is good, and it has undergone this process so well, then you'll find that report is different and is very comprehensive, and the interpretation has been done properly, and there is no variable which is not interpreted within the context of what was being investigated in that particular study. And even if it's for the report for the NGO, that is exactly how it's going to be done. Let's move to the next level. So the data cleaning, what does it involve? Identifying missing values. There are values that are missing, like when a respondent has not given us, has skipped a variable. It may has skipped the variable because that particular question is intimidating to him or to her, or that particular question is trying to dig deep to their personal life. They don't try to respond to it. Some other people fear you going deep to their personal life. They don't want. Yeah. So if you start asking them the number of children they have, when they got married, and probably perhaps how many times do they spend in their performing their marital duties per week, they don't respond to such. So those questions will be left unfilled. And it is your responsibility of the researcher when you're doing pilot, when you find a lot of some questions being not filled, you modify those questions to make them more friendly so that the final study, the responses will be higher, not as a case. That's the essence of pilot. And actually, pilot study is very, very important. You should not do any research without doing it. Correct inaccuracies, incorrect values, typos, or inconsistencies are also, this is the place where we are doing what we call eliminating those inconsistencies. We also do what we call standardizing the format, especially when it is date. Let all my date be in a specific date format system. If date first, then month, then year, and year is 25, or year is 2025, let it remain the same. So that's what we are calling as standardizing. We standardize all the values also. Sometimes we even standardize values that are mixed up, numeric, categorical. We standardize them so that at least we can be able to have better meaning of it. Currencies are also being standardized. Units are being standardized. Then normalization. Normalize data by scaling numeric values to a standard range or by converting categories into a common format. Like when we now key in data in terms of dummy, 0, 1. Now, that is one way by which we can now use that particular data for even when I was running a quantitative analysis like regression. And the kind of regression I was running involves numeric values. That particular data set, categorized or grouped in that manner, I can include it now in running that particular kind of regression. That one now will come up later when we are looking at data types and various analyses that are present, available for each. Address outliers, I've talked about it. Validate data integrity. Validate the integrity of your data by checking for logical errors or inconsistencies. And document changes somewhere where, if at all, you have been asked. And this process of documenting changing is very, very important, especially when you'll be given assignment by the NGOs. They expect you that don't overwrite any change you are making, but create a sub-variable where you are going to work on so that the original one is still left there for easy tracing about the trail. And then you can be able to give them the report indicating all the processes that you have done to that particular data for proper validation. Okay, that is also very common in most of the NGOs. They require you to provide that report on anything that you have done to that particular data set. That report is available and they can be able to go over it just to perform their validation checks. A part of the cleaning of the data is to understand my data, and therefore I can do what you call transformation. When I call about transformation, this is something that we used to do when we are still very young. We never knew, we had not introduced ourselves to the concept of data so much. When I was in high school, there was in my maths class, there was my maths and physics class. I used to do the transformation aspect, and I never knew. There are some instances when I was doing physics and a practical physics in my final exam, and the graph I drew was actually a curve, but I was expected to convert that curve to a straight line. And one of the things that I did was to take the logarithm for both the x side and then the y side. And actually the final result is that curve was converted to a straight line. And after that, I was able to use that straight line to do what you call estimations that I was supposed to do. That concept that I was doing in high school is this concept we are calling as data transformation. It can either be of mirror lines, transformation using some scale factors. It is also here. That is exactly what is here. So here, what we are going to do is that some of our data set will not have what we call normal distribution. There is a normality test that we are going to perform. And if it proves otherwise, like all categorical cases are mainly associated with non-normality. So you will do some test to convert those variables that are non-normal, especially the dependent variable, so that you convert it now to have a normal distribution. But if it fails completely, then you are going to choose statistical tests that accept data without that normal distribution, and you run them. That simply means I will be talking about various tests. These are tests that only require data to be having a normal distribution. And the normal distribution is a curve. It's a bell-shaped curve that we shall be looking at when we go to the software. It comes out automatically indicating a balanced kind of a curve in both sides. There's some element of balance. But if we lack that normal distribution, which means there was the population where we drove the data, or the people we sampled to give us the responses, they are not having a normal distribution, then it will have some element of skewness. It will be kneeling towards one side. So either it will going to kneel towards left, the curve will be kneeling towards the right, or kneeling towards the left. So in such a case, we shall have remedy on how to be able to approach them so that you can have that normal distribution. And those elements of remedy, approaches to the remedy, are what we are going to call as transformation. Yeah. And then we do all this. This was at advanced level. We do principal component analysis. I will also be explaining how relevant is it, especially when you want to check the dimensionality of your data, so that you know, definitely get sure that the variable that you are trying to investigate, all the element, all the questions are supporting that variable. Not you have a questions, you have 10 questions, but then 3 questions out of 10 are measuring their own things far away from the variable of investigation. So we must be able to eliminate those particular questions that are far away so that we only remain strictly with the questions contributing to us understanding the variable we are trying to investigate. There is much that we are going to do in understanding our variable and how they can be able to clamp together. Yes. Okay. So the data analysis process is what we are trying to underline. Careful data analysis begins from having a plan. You can never do it without a plan. It's not done haphazardly. The plans will contain what type of data you have, when and how you will analyze them, and how you will use the result to get other further meanings. So how you analyze data depend on the data type. And the data type is what I've just talked about briefly. Discrete, continuous. Then I talk about binary. Then I needed to talk about ordinal, ordered responses. Response that you can easily see, this is the smallest and this is the highest level. Like for instance, when you look at the level of education of the respondent, some just left in their primary level, others left in secondary, others went to college, others went to undergraduate, others have masters, others have PhD and postdoc, etc. So education level can easily be ranked from smallest to the highest. Such data types that you can rank are the ones we are calling as ordered, ordinal responses. If you want to go to a village and try to understand their income levels, you can categorize income levels into 3 categories: lower income level, middle income, and higher income level. Now, if I go to respond number 1, they must fall within one of the categories. And that's why we call that particular data set to be ordinal responses. Another ordinal response is the one introduced to us with Professor Likert. Professor Likert introduced us a Likert scale, a scale you can use to order responses. Initially, when it was started, by the year 1930, the only measurement we are using it for was level of agreement. Yeah, you are trying either to measure the level of agreement of a service level you are provided to the respondents. So you're asking them a question: how did you find our hotel services? Then you give them 1. Our hotel services are excellent. That is the question. Then 1. strongly disagree. 2, disagree. Then 3, neutral. Then 4, agree. Then 5, strongly agree. Now, based on a person, especially if it's an exit interview we are conducting to our visitors, if the visitor was happy with our services, we expect responses that are ranging from 4 to 5. But if the visitor was not satisfied with our services, then we expect 1 to 2. Now, the choice of 1, 2, 3, 4, 5, we are using 1, the smallest, in case the statement we are writing there is a positive statement. This is something that people do not know. They only think about Likert scale 1 to 5, and they don't know when do we reverse the scale system and when do we accept the lowest to be strongly disagree. Strongly disagree 1 being lowest is only used when we are having a positive statement. But when I'm having a negative statement, then I reverse the order. So now, what will happen now is strongly disagree, which was initially 1 in a positive statement. Now, the one that is going to be strongly disagree is 5. The highest level scale, you bring it to be 5 now. And now, strongly agree will be 1 if the statement was negative. If you provide a negative statement, and in research, we don't expect to vary the scale. You maintain a specific standard of setting your questions. If all of them, if they are negative statements, let them all be negative statements. If they are positive statements, let them be all be positive statements so that the scale level remains the same all throughout to support the analysis and getting inferences from them. But after the founder of the Likert scale, now this scale system has been explored extensively to be used in various other areas apart from the level of agreement or disagreement. Currently, we only use it in satisfaction level. So there are so many other ways now they are getting in, and various disciplines that now can be able to use the Likert scale. Yeah, and they keep on now changing a lot as a result of further research in just what you call the Likert scale. I once read just a PhD dissertation of someone who just, the study was about Likert scale only. I read a lot of it because I was interested in understanding the controversies surrounding the choice of a statistical tool when it comes to ordinal measurement and also nominal variables versus the numeric variables. Yes, and the student explored when to use the Likert scale very well. Yeah. So when I talk about the Likert scale, the appropriate use of Likert scale and the new development that is associated with it. There's one a recent professor who came up with an investigation, and from him he recommended currently we can be able to use Likert scale with we can now use Likert scale running parametric test statistics. so long as some conditions have been observed, like normal distribution. So long as it's already been observed, we can use, because when we talk about mean average of a certain variable, the mean tends to be a continuous variable. Somebody just picked one, another one picked two, another one picked three or four. Then you add the 5 responses. And in often cases, you'll find we are dealing with what you call odd numbers. So you add the odd numbers, you divide by 5, the value you are going to get most likely is going to be a value 3.4, 4.5, or 4.7, which by denotation is a variable we can conclude is a continuous variable with some element of decimal in it. And that is how you support it. So even if you find a research somebody is using Likert scale and now running multiple linear regression, there's nothing wrong with that from that particular paper that was presented. But initially, the first work that I read, it was no, you cannot use a Likert scale and run things like multiple linear regression or correlation. That is the first paper. But now after this new development, now it has been opened. So long as you can be able to ensure that you do your transformations well and your dependent variable can have a normal distribution, well and good, you can proceed with it. And from that, if you go to most of these libraries, you find majority of the students are using ordinal measurement in running multiple linear regression. There's nothing wrong with that. How you analyze depend on the type of data. Quantitative data are analyzed using quantitative statistical methods and computer packages such as Microsoft Excel, SPSS, Stata, then eViews, and then you also have Python and R. The result of quantitative data analysis are numeric and easily visualized using graphs and charts and map. Being numeric means they are in numbers. So when I have a categorical response, I must present them with some number equivalent. So if I have level of education, then I introduce it. So then I can be able to rank those responses very well. Okay. So now, qualitative, on the other hand, is mostly often done by reading through qualitative data in the form of transcript or notes from focus group discussion or interviews. This process is called content analysis or thematic analysis. It can be aided by software such as Atlas or NVivo, or mutually by using paper and pens. Like here, it's very cheap to do the softwares with us. Like the NVivo, we have one of the professor who is doing it, training it so well, Professor Rasak. Even right now, we are doing what we call recruitment for those who want to attend the NVivo software with the professor. So he normally training it so well, and within only 5 days only. And the result is excellent. So if at all you want to analyze qualitative, and this is like a must, I normally tell people, don't hurry that you think that it's only quantitative analysis that matters. Qualitative currently is very important because majority of people we collect data from cannot even read the questionnaire. So it's only through interview that you can be able to gather data from them. And that's why if you are interested in the research field, you must combine qualitative and quantitative. You cannot only depend on one. It is the quantitative that gives us the detail of the matter. we even come up with theories because of qualitative. The professor will tell you how you can generate theories out from the study that you are conducting using this software called NVivo. So it is usually very important that I come in both. I can analyze quantitative and I combine with qualitative because all research, they will tell you use mixed method. What are those? Combine both qualitative and quantitative together so that you can provide your report. That is how most of those research are. The recommendation is to use mixed approach. There are many benefits for this approach, including better management of challenges and timely learning and adaptation. Let me just even try to move very fast so that I can have some little time for questions. Let me just move. Okay. I'm trying to take you through what we call the variables, but these are not very important because when we come to the analysis itself with the real data set that we shall be using, it will be like a repetition where we shall talk about understanding how to analyze the moderating effects of the variable, test on the moderating effects, whether it is significant or not with the softwares that we already have. So we shall test for these moderating effects. We shall test for the independent and the dependent variables on the same manner. The mediating effects, which is also some of the tests that we shall be performing, mediating variables, okay, intervening variables, and the control variable. So you will come out from this particular training well equipped and being able to start practice on your own. And when I train you, one thing that I will advise you, let me train you when you already have a certain, there's already some data that you can, there's something that you're already doing that is concerning that data, the concerning analysis, so that you'll use the knowledge immediately to start going deeper over it. There's a young man that I trained some times back. Right now, when he sent me the report that he generated, I was so much happy because the guy has used the knowledge very well, and currently he even told me that he wish he knew would have learned this thing slightly earlier. But if you train and then you go and sit down there and forget about everything, when you start again, you'll come and repeat it again, is when you can pick up. But even if you repeat again, there's no problem. If you are there, it's still there for you. So me, I welcome you guys. Even if I tell you you already done it before and you want to have the next experience, please enroll for this particular training course so that we shall be running it for the next 2 weeks. So move with it for the next 2 weeks. So it's going to be very comprehensive, and we shall leave you when at least now you are up to the game. You can analyze both types of data sets that we already have, be it categorical variables or we are having numerical variables. And in case any flaws has been observed, you can also be able to rectify because that is under preliminary an assessment of your data, which is very critical for you to make a decision on the kind of analysis that you're going to perform. And especially when you are making what you call your data analysis plan. So you can plan appropriately how you are going to analyze those specific variables. Otherwise, I may not be able to complete the question because I want to give some moment for interaction. So we remain with 25 minutes where we can have some interaction. So thank you so much. May God bless you as you are going to decide on enrolling for this particular training course. It's very small. Actually, you can't get the knowledge that you're going to get here with the 5,500 only for the next 2 weeks. So join us and we shall really appreciate all this. We shall be able to repeat them when we are doing what you call the practicals. Yeah. So that's all about what I wanted to present to you today. So thank you so much. God bless you. Any concern, let me now stop recording so that we can have some interaction, some questions, and we can be able at least to end well.